the Science Guy. Bill Nye, the Science Guy. Bill Nye, the Science Guy.
Science rules.
Bill Nye, the Science Guy.
Inertia is a property of matter.
Bill Nye, the Science Guy.
T minus 7 seconds.
Bill Nye, the Science Guy.
Welcome to Bill Nye the Science Guy. Now, clearly I am not Bill Nye, but I will be substituting for him today. My name is Cheminsiya. And today, boys and girls, we are going to be learning about... Wait for it. Plastics and other polymers. You may be thinking, plastics, polymers, ugh, boring. No. Plastics and polymers are very interesting. They're all around us. In this box, in this bottle, even in this cellophane wrap. Even my hair, and my shoes, and my sweater is made up of polymers. You must be wondering, just like I am, what are polymers? The word polymer is derived from Greek, the word poly and the word mer. Poly means many and mer means part. When we put it together, polymer means having many parts. Polymers. Now you may ask, what are these parts that you talk about, Cheminsiya? The parts that form a polymer are known as monomers. Monomers are defined as atoms or molecules that chemically bind together to form chains or polymers through the process of polymerization. I'm sure by now you've figured out what polymerization is. Polymerization is essentially the process by which monomers chemically bind together to form polymers. This next video by the TT Science Club, thanks to YouTube, very nicely sums up what I have told you about polymers, monomers, and polymerization. Hope you enjoy it. We will have a look at that video again later in my presentation when I go into the depths of polymerization and talk about the condensation and addition reactions and the plasticizing effects of plasticizers. But now, just hold on to your horses because it is fridge magnet time! Oh yeah. We are going to use fridge magnets today to learn about the two reactions of polymerization. Addition reaction and condensation reaction. First, however, we're going to learn about condensation reaction. Here I have one monomer. This monomer contains a hydrogen and a hydroxyl group. Let's have a closer look. A second monomer similarly contains a hydrogen and a hydroxyl group. When the process of polymerization occurs in this condensation reaction, one of these monomers lose their hydroxyl group, while the other loses their hydrogen group. The electrons that are unpaired in these two then join together to form the covalent bond. On the side, however, we have a water molecule produced. This is the condensation reaction, which is also used in polymerization. Next, we're going to have a look at the addition reaction of polymerization. The addition reaction requires us to be a little more specific, so we're going to use the example of the formation of polyethylene. Therefore, the monomer that forms polyethylene is ethylene, whose formula is C2H4. So here we go. We have a C here, and we have another C. The carbon obviously has 4 electrons around it. Thus we can see that a double bond forms between the 2 carbons. And the 4 hydrogens are around the carbons, and the hydrogen has 1 electron which bonds with the unpaired carbon electron. To show the binding of the 2 monomers of ethylene, we're gonna have to make another monomer and another Lewis diagram of ethylene, which also contains 2 carbons and is exactly like this one. Now, ethylene, as you know, is a gas. And the amazing thing that happens to ethylene as a gas can be seen in its polymerization. When an ethylene gas molecule is struck by heat, high energy radiation, it causes something amazing to happen between the double bond of within the ethylene molecule. It causes one of its electrodes to shift to the side, which leaves this one unpaired. Thus it moves to the other side of the molecule. This arrangement triggers this ethylene molecule to do the same, starting the chain reaction. These 2 monomers join together, and as this continues, a chain forms of ethylene molecules, thus forming the polymer polyethylene. Polyethylene is the most common type of synthetic polymer. It is a plastic. Now, there are 2 kinds of polyethylenes. Type 1 consists in long straight chains, which can consist of 25,000 to 50,000 carbon molecules. This type of polyethylene is called high-density polyethylene. Examples of high-density polyethylene are bottles, buckets, jugs, containers, toys, even synthetic lumber, and many other things. The high-density polyethylene that has up to 500,000 carbon molecules are tough enough for synthetic ice, replacement joints, and bulletproof vests. The 500,000 carbon high-density polyethylene is called ultra-high molecular weight polyethylene, or UHMWPE. The second kind of polyethylene is low-density polyethylene. Low-density polyethylene is made by causing the long straight chains of carbon and hydrogen to branch. That way the chains cannot link next to each other, making the density of the polyethylene less than the high-density polyethylene. Low-density polyethylene, however, is lighter and more flexible. Examples of it are plastic bags, plastic wraps, squeeze bottles, and many more things. Just take a minute to think about this. You start off with ethylene gas molecules that can't stop a feather from passing through them. But after the double bond of the ethylene molecule breaks, it causes a chain reaction that connects thousands and thousands of ethylene molecules together. In less than a second, these long straight chains of carbon and hydrogen aligned next to one another are strong enough to stop a bullet. Other plastics include polypropylene, which is used in car trims and battery cases. Then there's polyethylene terephthalate, PETE. And then there's polystyrene, PS, which is used in styrofoam making. Last but not least, there is polyvinyl chloride, PVC, which is a very brittle thermoplast and has plasticizers added to it to make it more flexible.
Sing no matter where you are, the cucaracha, sing it on your guitar, the cucaracha, sing no matter where you are, the cucaracha, sing it on your guitar. But this much better, better than I didn't know better, but that is there, but I didn't know that
In summary, monomers join together to form polymers in the process of polymerization. The rate of polymerization can be increased by increasing the temperature of the chamber of polymerization, by increasing the pressure in the polymerization, and by monitoring the color and the pH of the solution. Polymers include plastics, nylon, polyester material, my hair, wool, all kinds of things around us. Now that we've learned everything there is to learn about plastics and other polymers, I say sayonara from Cheminsiya. Bye-bye.
T minus 7